Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem 50, POW x n. This is a classic problem, often showing up in coding interviews, and it's a great way to practice our dynamic programming skills. The problem asks us to implement the POW function, which calculates x raised to the power of n. Seems simple enough, right? But there are some important constraints to consider. We need to handle negative exponents, and we need to be mindful of potential overflow issues with large numbers. So it's more challenging than it initially appears. We'll explore different approaches to solve this, starting with a naive method and eventually landing on an efficient dynamic programming-based solution. Let's dive in. Understanding with examples. Let's solidify our understanding with a few examples. If x is 2 and n is 3, the answer is clearly 8, because 2 to the power of 3 is 2 times 2 times 2. Simple enough. Now, let's consider a negative exponent. If x is 2 and n is negative 2, the result should be 0.25, which is 1 divided by 2 squared. Notice that we're dealing with floating point numbers here. Finally, let's handle a larger number. If x is 2.0 and n is 10, we should get 1024.0. These examples highlight the different scenarios we need to accommodate in our solution. Understanding these edge cases is crucial for building a robust and correct algorithm. Now, let's explore a straightforward approach before optimizing it. Brute force approach. A simple way to calculate x to the power of n is through repeated multiplication. We could use a loop, iterating n times and multiplying x by itself in each iteration. This is our brute force approach. However, this method has a significant drawback. The time complexity of this approach is O of n, meaning the runtime increases linearly with n. For large values of n, this can be very slow. Furthermore, for negative exponents, we'd need additional logic to handle the division. It's functional, but definitely not efficient. Let's see how we can improve upon this using a more clever strategy. Optimal solution. A more efficient approach involves a technique known as exponentiation by squaring. This reduces the number of multiplications significantly. The core idea is that x raised to the power of n is equal to x raised to the power of n divided by 2 squared if n is even. And if n is odd, it's x multiplied by x raised to the power of n minus 1 all divided by 2. We recursively break down the problem into smaller subproblems until we reach the base case. This method drastically improves the time complexity, bringing it down to O of log n. This is a massive improvement over the brute force approach, especially for larger values of n. This recursive approach, combined with handling negative exponents and edge cases efficiently, will provide a highly optimized solution. Code implementation. Let's see the code in Python. We will implement the optimized solution using recursion and handle negative exponents and edge cases. We'll first define a helper function to handle the exponentiation by squaring, and then build the main function to handle all possible inputs. Code will be displayed here, with narration walking through each line, explaining the logic and purpose of each section. Narration should highlight the recursive nature of the helper function and the handling of negative exponents. This implementation is concise and efficient, leveraging Python's power and readability. Time and space complexity. Now, let's analyze the time and space complexity of our optimized solution. The time complexity is O of log n, due to the recursive nature of the exponentiation by squaring. Each recursive call effectively halves the exponent, leading to logarithmic time complexity. The space complexity, however, is O of log n as well, because of the recursive call stack. For very large values of n, this could potentially lead to stack overflow issues, so in a real-world scenario, you might consider an iterative approach to avoid this. We could convert the recursive solution into an iterative one to reduce space complexity to O of 1 while maintaining the logarithmic time complexity. But for this problem, the recursive solution is elegant and easy to understand. Engagement break. So, there you have it. We've successfully tackled the POW x n problem. Before we wrap up, don't forget to like this video if you found it helpful. Hit that subscribe button to stay updated with more LeetCode solutions and algorithm tutorials. And let me know in the comments what other LeetCode problems you'd like me to cover next. Your feedback helps me create more valuable content for you. Let's continue. Conclusion. In this video, we've explored different approaches to solving the LeetCode POW-XN problem. We started with a naive brute force approach and then moved to a much more efficient